Hi everyone, welcome to the channel. If you're new here, what we have are software engineering interview questions and how to use various technologies. And if you've been here before, welcome back. If you like this content, please follow me on social media to get the latest updates, and also check out my website for supplementary material as well as similar content. Without further ado, let's get into it. So this problem is called longest palindromic substring, and we're given a string S, and we want to find the longest palindromic, not sure how to pronounce it, substring in S, and we want to assume the maximum length of S is 1000. And here we see we have BABAD, and BAB is the longest palindrome since the letters are the same when you reverse the string as the original string. And we see for this one, it would be BB. And so for this problem, what I was thinking about is possibilities and cases for palindromes. And so palindromes can be odd or even, and we can see from the example. So we see we have BA, BAD, and for odd palindromes, the center starts with letter. So that's why we have BAB. Then we see second example, even palindrome with space or no letter. So the reason why I'm talking about centers is that the naive solution would mean that we scan through each of the positions inside our string. And for each of those positions, we would expand from the center to check if there's a palindrome. Or if we don't expand from the center, then we try every single substring. We go to each center and then try every single substring and then check if that substring is a palindrome. And that will take O of n cubed. And to speed up the solution, what we can't get around is we must go through each of the indices. So that would be O of n, because each of the indices could be a start, or it could be the center of the palindrome. And to speed up the process for palindromes, we start with the center and we expand to the left and the right. And so if we, for instance, we started with A, from the first example, we see that, okay, we start with A and then we look at the center, or we look at the moving pointer for left and pointer for the right, and we see we have BAB, and that is a palindrome. Then we continue, and then we see we have A, and then out of bounds. And so at this point, we know that, okay, that's not a palindrome. And so the longest palindrome for the center of A, which is here, is 3. And so that way we have a slight optimization, and so the solution we'll be working on will be O of n squared. And so, yeah, as I was saying, I've said starts with space or / no letter. I like to change the string BABAD into BA and then have a space. And here we see the indices 0, 1, 2, 3, 4, 5, 6, 7, 8. We would go through each of the indices, so then here's a star to denote which center we are on. So we start with the center and then expand to the left and to the right. We see the left is a space, or left is out of bounds, right is out of bounds, or right is a space. And so the best substring here would be 1, and it would be B. So that would be for that center. Then I move here. For this center, we see that A and B on the left and right, they don't match. So the greatest length is 0 since we have a space. And then we move on to A. So for A, I see the left and the right, we have a space, so that is a palindrome. And I could denote this L, kind of shifts, but maybe I don't need to write it down and you'll be able to follow along. So I check left and right, and because they are both spaces, now I could check and move the pointers to left and right even more, and I see I have BAB, and so okay, it matches, and I continue, I see a space out of bounds, so the longest substring is now BAB with 2, or size 3, 3 letters BAB. And then I can continue. And you see here, similarly, it's 2 spaces, so I move the 2 pointers left and right. You see AA. Okay, great. Move the 2 pointers, 2 spaces. Great. Continue to move the 2 pointers, and I hit B and D. So then at that point, I know that we don't have a palindrome, and so ABA is another solution. And we see in this case that it says ABA is also a valid answer, so we know that even if we have ties in palindromic substrings, we can choose whichever one. That's an important thing to ask the interviewer if we don't see this note. That way we can make sure we're solving the problem that they want. And so yeah, this is the main idea for the problem, and we have enough to code through this. So the first thing is that I made these spaces so that we can expand from the centers. And so to make the space, we'll do S, and then we'll do join. And when we'll join for every single letter within S. And so this will yield a space between each of the letters, transforming BAD into B space, A space, like so. Now the next thing is we want to cache the length. That way I'm not always computing the length. So I know how many letters there are. And then the max length, this is what we want to return. Initially it's 0, and then start equals 0, end equals 0. Start denotes the starting indice of the longest substring, and end denotes the longest end point of the substring, palindromic substring, since at the end we want to output BAB and BB. The next thing is we have a function called def expand. This is where we expand from the centers. And like I said before, we have to go through each of the indices. So I in range, go through the length, and then a few things we need to check is if the cur length is greater than max length, right, after we call expand. If the current length is greater than max length, which current length I need to take from the expand function. And so expand, we wanted to return the current length of the longest substring we find, as well as the indices, so we could update start and end. So we'll call that cur left, cur right. Yeah, I prefer to have the indices in the beginning and then the length at the end. And so we will have current left, current right. Those are current right, left, and current right are the left and right indices, which, for example, if we have BAB, okay, so if we have the center here, the current left would return this position and this position for the current. This is the current right, and this is the current left. And then length would be, current length would be 3. So if the current length is greater than the max length, then we'll update max length equals current length, as well as update start to equal cur left, and end to equal cur right. At the end, we will have found the best substring, and so we'll index from the start n+1, because whenever we indent, we slice, Python will go up to the end -1. And so if we want end is the last position that we want to include, we'll do n+1, n+1 minus 1 will give us end, up to end. And then we will want to replace all of the spaces that we created to expand from centers, which we did up here. So we use .replace for string, and then we find all the spaces and replace them. Now we write our expand function, how to get cur left and cur right. So when we expand, we have this center, and then we have a left and we have a right, which is off by 1. So we say left equals I minus 1, right equals I plus 1. The next thing is we want to have a cur left and cur right, which marks the valid indices for a palindromic substring. Because initially, if we just have one center, it's possible that the left and right are not valid. So we just assign just a random number to initialize. And then the length of our palindromic substring is 0 if we're expanding on a space. And we can use is space to check if it is a space. And if it's not a space that we're expanding from, meaning we're expanding from letter, then its current length is 1 because a single letter is always a palindrome. Okay, and then while the left is greater than 0, meaning that we are in bounds, and also right less than length, which we cache up here, length of s, we can continue our algorithm. And so we check if s of left equal s of right. And that's kind of like us expanding the center. We check, are these two spaces the same? If so, proceed. They're the same, so we proceed. And so if it's the same, then we want to update our current length. And it will be 0 if s of left dot is space. So if we have a space, then it's not adding to the palindromic substring. Otherwise, we add 2 because both the left and right are being checked by the pointers. And then we update cur left equals left, and as well as cur right equals right. Last thing we do is we move the pointers. Yeah, so I did make a few issues before I submit the correct solution with just using left and right. And the reason why we have to do this minus equal 1 plus equals 1, have a cur left and cur right, is that we will need to move the pointers, but once we move the pointers, it's possible that they're not part of the palindromic substring. So we don't want to return those in the end. And our else case is we break out of this while loop, and then we turn the cur left and cur right, and as well as cur length. All right. Do a quick check for this problem. So first thing is we take s and then make a space, length s max, start. All right. And then we iterate through indices, length, get cur left, cur right, cur length from expand. And then if the current length is greater than the max length, then we'll have max length equals current length. And then update our start and end with cur left and cur right. Yes. And then we go from start to n plus 1 and replace the spaces. Here, the centers, we have left I minus 1, right is I plus 1. Cur left, cur right, just initialize to 0. And then length is 0 if we have this space. Make sure it's in bounds. Left has to be greater than or equal to 0, and right has to be less than the length. If it is palindrome, then we increment the length. If it's space, it's 0. Otherwise, we add 2 letters. Update cur left and cur right. Move the pointers for left and right. And then, yep, that looks good to me. See if it does work. All right, great. Looks like it works. And runtime is open square, like I was discussing before. Since we go through each of the indices, every time we call expand, when we call expand, it's possible the substring worst case would be all palindromes. So it could be something with all one letter. And then, yeah, each time we call expand on every center, every single possible substring is valid. And so, yeah, that would be O of n squared. And then for space, we have O of n, since we make n is the number of letters in string S. It's because every time we have a letter, we're putting a space in between it. So yeah, the O of n space complexity. And I think it is possible to do this problem with constant space complexity. Just have to be a little bit more clever on how we're moving and expand. So that's one thing to improve on for this problem, is to change the constant space. And then there's also an O of n algorithm, which is called Monaker's algorithm. And that one is like for the go-getters. So like maybe I'll do it later. And yeah, but otherwise this problem is O of n runtime and or O of n squared runtime and O of n space complexity. So yeah, it should be good enough for interviews. And if not, could look into Monaker's algorithm, improving the space complexity. Yeah, so I guess, yeah, I hope you guys all learn as much and have as much fun as I did. And yeah, be sure to like the video and subscribe if you want more content, and follow me on social media for the latest updates, and check out my website. Without further ado, well, I guess this is the end of things. So last thing would be, yeah, I hope you guys all enjoy the rest of your day.